Hello. Hello, Fred. Fred, can you hear us?
Good morning. Good morning.
Hello,
Good morning. Great technology here. I can see most everybody. All right, is Victor there?
Yeah, I'm here, Fred. I'm here. Everyone is looking forward to hear you.
All right. You want ready for me to go ahead? I'll be set.
Yeah. You can go right ahead. First, speak out whatever you want, and then we will have a question and answer session.
Okay. All right. I don't know how much background you've had, but my name is Fred Hayes. And you're looking at me in an office I have in Houston, Texas. And we have a little bit of an echo. Can y'all hear me okay? Can you hear me okay?
Yeah, we hear you okay.
Okay. And I thought I'd tell you a little bit about how I got to be an astronaut and fly to the moon on Apollo 13. As I grew up, got ready to get higher education, I actually was planning to be a journalist. And in fact, the first 2 years of college, that was my major. I worked on a newspaper, editor, and in summer times worked on the local newspaper as a reporter, cover reporter. But what changed all of that was the Korean War. I volunteered to serve my country, and the only program I could get into at the age I was, and my father had always said, try to become an officer to get a commission. And the only program that fit was the Naval Aviation Cadet Program. So I joined to become a pilot. Now that was a bit strange because I had never been in an airplane in my life. But that's what, for an 18-year-old, sometimes you don't think too hard about what you're getting into. But as it turned out, I loved flying. From the very first time I was in an airplane, this was a new passion. And I knew somehow this was going to be my life's career. It's going to be in aviation. I have to realize this is 1952. So 1952, there was no space program. So I could not want to be an astronaut. But at any rate, I went through the aviation program 14 months, qualified on aircraft carriers, ended up serving in 2 U.S. Marine fighter squadrons. And about that time, I was thinking, well, what should I do next with my career? Should I stay and make a career in the military? And from books I had read, I decided I wanted to be a test pilot in test airplanes. That led me back to school to get an engineering degree. It's a requirement for everyone involved in test operations. And I got an engineering degree, aeronautical engineering degree. About the time I finished, I looked at working for various companies, but based on a recommendation of a squadron commander I had in the reserve squadron, I decided to check out NACA. This was before it had become NASA. But as I was just finishing school in my last year, the space program evolved with the Russian launch of Sputnik, and NASA was created. And so I was really applying to NASA centers at Langley in Virginia, at Ames in California, and found an opening at Lewis Research Center in Cleveland, Ohio. That's now named Glenn Research Center after John Glenn, our astronaut who first was in space. following a Russian, Gagarin. But at any rate, I joined Lewis as the test pilot and was there 4 years, and then moved to NASA's premier flight test for aircraft base at Edwards Air Force Base in California, Flight Research Center. I basically followed Neil Armstrong by about 2.5 years. Neil had started at Lewis Research Center in Cleveland. He had moved on to Edwards Air Force Base and NASA's Flight Research Center as a NASA test pilot. And Neil then joined the astronaut program. So I was following Neil down that same path and decided I was a little hesitant about joining the astronaut program because I was having so much fun flying airplanes. I remember one month at the Flight Research Center, I was involved in several test programs supporting the X-15 rocket ship program that was going on. And that month, with 1 month, I flew 9 different types of aircraft. So it was a lot of fun flying every day, and I had to think hard about joining the astronaut program and leaving that, which is still the most fun place I've been in my career. But the urge and thought of going to the moon was overpowering, and I knew I would not get a chance to go to the moon if I stayed at Edwards. So I signed up and joined the program in 1966. Now the rest of you know about, how many here have seen the movie Apollo 13? Anybody raise their hands? Yeah. A few have seen the Ron Howard movie. It was about our flight. The movie was dramatized in some respects, but overall I thought it told the right story. We obviously had a flight and ended up with a problem, a major problem that had to be dealt with. The cast, if it had the real cast, would have been much larger because there were a lot more people involved than what was shown in the movie. But anyway, these people, many who lost, probably got less sleep down here on Earth than we got in flight, figured out some things never thought they'd have to figure out to get us home. And I thought that we carried that theme of teamwork, the right people doing good things to get us home. So I thought it carried well by the movie. But at any rate, I stayed on. Actually, when I flew Apollo 15, I backed up Apollo 8. That was my first crew assignment. I was a backup lunar module pilot, Apollo 8. The backup crew was Neil Armstrong, Buzz Aldrin, and myself. Unfortunately, Mike Collins, who had an injury, got well, and he had seniority. So I ended up serving a second backup assignment as Buzz Aldrin's backup on Apollo 11 before I got to fly 13. The flight itself during that time was, of course, quite a disappointment because I'd done the work training to go fly 2 previous missions, and now I had my chance and lost the chance to land on the moon. Jim Hubble and I would have landed and gotten to walk on the moon. I went back into training, after about a month, after return from Apollo 13, as a backup commander on Apollo 16, backed up John Young, and had hopes of flying Apollo 19, which at that point in time was the last mission scheduled to go to the moon. Unfortunately, NASA's budget was cut, and they ended up canceling both Apollos 18 and 19. So I lost my chance to go back. I stayed into the program and worked and actually left the astronaut office and for years went to the orbiter project office to develop space shuttles, and then had the opportunity to go back to the astronaut office and was the commander of Crew 1. That 2 crews, only 4 of us got to fly the Space Shuttle Enterprise, and I got to fly the first flight we ever flew of that space shuttle, where we air launched off the top of a 747 aircraft, 1977, and I got to command 5 of the test flights we did on with the Space Shuttle Enterprise, that approach and landing test. So that's kind of my NASA career. I was slated to fly the third orbital mission, and had we kept the mission, I would have stayed to fly that flight. We would rescue Skylab, which was falling in, but unfortunately it fell in early as the shuttle flight schedules had slipped. And so I decided to leave NASA and really head out to a career planned, actually become an aerospace executive and program management, which I then joined the Grumman Corporation in New York and stayed on to become president of service companies. One, when we merged with Northrop Grumman Company, they both are airplane builders. Northrop builds the T-38s we flew, the B-2 bomber. Grumman built a lot of Navy airplanes, the F-14 Tomcat, still building the E-2C. It's an AWACS aircraft and aircraft carriers. And so I stayed on for 17 years, more in the business world, as an aerospace executive. So overall, I've had a great career. Stayed close to things I love, airplanes, space business, and been blessed with a 42-year career. Now I mostly work with not-for-profits on various boards, helping to raise money for museums and things like that. So anyway, now I thought we'd open it up for anyone has questions.
Yeah, just a second, Fred. We have some questions. Okay, first of all, you hear me okay?
Here it's still a little echo for some reason. Go ahead, we'll try.
Okay, we will handle the echo. First, I want to ask some pre-written questions, and then we'll let the public ask you their questions. So first of all, the most important question. Apollo 13 is known as the best example of handling and recovering from the difficulties of space. What is your message to Space IL and the Israeli aerospace industry's engineers about the failed landing of Bereshit 1 and the future Bereshit 2?
Boy, I don't know. Sorry, I could not get it. I don't know, maybe you talk a little slower on the question.
Okay, no problem. I will ask again. Apollo 13 is known as the best example of handling and recovering from the difficulties of space. What is your... You can't hear me?
No, it's just garbled. I don't know if it's your mic or you're holding it too close, or maybe someone else.
I will try without the microphone. Apollo 13 is known as the best example of handling and recovering from the difficulties of space.
Yeah, that's better. Yeah.
Okay. What is your message? What is your message to Space IL and the Israeli aerospace industry's engineers about the failed landing of Bereshit 1 and the future mission of Bereshit 2?
No, I somehow didn't get the last. I know you said Apollo 13 is a good example of I guess, a challenge in space, but I couldn't get the rest of that question.
What is your message to Space IL and
what is my message to who?
To Space IL. Space IL it's the organization that sent a lunar landing to the moon. It's called Bereshit. Bereshit. It's the first lunar landing of Israel to the moon.
Victor, it's not coming through there. I'm sorry.
Okay. I will try to write it down, okay?
someone else.
Yeah, I will try to write down the question. Just a second.
Okay, now I hear you. Now I hear you.
You hear me now better?
Yeah, now no echo there for some reason.
Okay, perfect. So Apollo 13 is known as the best example of handling and recovering from the difficulties of space. What is your message to Space IL and the Israeli aerospace industry's engineers about the failed landing of Bereshit 1 and the future mission of Bereshit 2?
I'm sorry, the message to the European Space Agency, was it?
To Space IL, the organization that sent the first private lunar lander to the moon.
Oh, okay, this is the recent mission that had a problem. Is that it? To land on the moon, a recent mission?
Just a second, and now I'm not hearing you very well. Can you repeat, please?
You're referencing the recent mission with the attempted landing on the moon?
Yeah, exactly.
Okay.
Exactly.
Yeah. No, I think it's a case of that. That obviously was the first mission. Apollo 13 was not the only mission that had problems. If you're doing things for the first time, be it aircraft tests, or in this case, a space program mission, you can expect that you might have problems. That's why first flights are always, frankly, treasured by a test pilot, because you're going to be the first one to try things out, and you try to prepare as best you can, look at all the possible failure modes, and prepare to handle those, either in your design or in workarounds you might be able to do in flight. But there's always that threat when you're doing things the first time that something will have been missed, particularly if it's a very complicated mission and a very complicated vehicle, which most spacecraft are. So it's but like anything, with an accident in an aircraft, or an incident like we had or other missions had in the Apollo program, you learn from those problems. And you obviously try to understand what the cause was, what the causal effects were. And for your next attempt or your next vehicle, you make those corrections. Be they possibly might be changing the vehicle, the hardware, or in the software that is involved in accomplishing the mission. And of course, something like you're talking about the mission Israel had in landing on the moon, there was not a person aboard, it was an unmanned vehicle, so it was more heavily dependent on the software. In the case of our vehicles that landed on the moon, all the last part of those landings was done manually by the pilot, looking out the window, so to speak. And we had to, because you did not know the terrain locally where you were going to land. So it depended on looking out the window and surveying to pick a smooth enough spot to land the vehicle. So the software didn't play as critical a role in affecting that last part of the landing.
Just a second, Fred. We will write down the next questions. We will write it in the chat window of Skype. It will be easier.
I'm afraid the person's going to have to come up to wherever you are, Victor, because that's the only place that doesn't have an echo.
Okay. We are writing down the questions in the chat window of Skype. That way you can read them, and I hope that way it will be easier for you to answer them.
Okay.
Just a second. We're writing down the next question. Okay.
All right. Do you think we should explore the moon? Yes, by launching satellites. Well, not just yes. You can any new place we tend to go. it's obviously good to have advanced reconnaissance, be it the moon or Mars or any other body eventually we go as we move outward that you would like to explore. You'd like to have that intelligence of both to several ways, both to pick out the places that would be most interesting to land and also to understand the terrain for the lander that the lander may have to navigate and overcome in its landing. So satellites are good for that if they have the right camera equipment to get and other probes and sensors to get the right definition, or previous unmanned landers, like Israel has done. China recently did one that landed on the backside. And obviously, the closer you get to the surface, the better definition and quality of what you're looking at. So yes, all those means, and that has been the way we've gone, though. Earlier, even before Apollo landings, we had both an orbiter, lunar orbiter, and we had Surveyor, which were probes that landed on the moon to get that advanced knowledge and intelligence about the place we were going to attempt to land.
Okay, next question.
Which topics are important? Well, that depends on the architecture of what you're building, and assuming you're talking about people going there to build a colony and stay. I know of interest that they've said is the North Pole, which has craters that are never, at least in the depths of the craters, are never exposed to sunlight, and ice has been detected, large quantities of ice. And obviously ice is a mixture of hydrogen and oxygen, which if you land near enough to get to those quantities, can be converted into gaseous forms that could be used obviously for breathing, but also talking about even propulsion means to eventually build from this lunar base the possibility of launching other vehicles. The lunar gravity is much less than the Earth. It's 1/6. So the energy required to leave the moon is much less than leaving the Earth. For instance, if you were in Earth orbit, you're at, I don't know how to put it in meters, it's roughly 18,000 miles an hour. We left to go to the moon at 25,000 miles an hour. Lunar orbit, on the other hand, to stay in lunar orbit is only a little over 5,000. So compared to 18,000. And similarly, when we left the moon, we were normally about 7,000 miles an hour versus 25,000. So with the less gravity, it takes a lot less energy to stay in like an orbit or to land, and much less to leave if you wanted to go even to places other than the Earth.
Okay. We're writing the next question now. Just a second. Okay, here is the next question.
I think any program, obviously, in space is expensive, and so any means that you can get the job done for less money is obviously an advantage. I think in the United States, obviously, for getting up and down in orbit, NASA's hopes are to use commercial companies to get people up and down, both SpaceX, which will utilize a capsule, and has been busy carrying cargo up and down the space station, rather than NASA with the space shuttle. And Boeing has a vehicle that's also intended to carry both cargo or people up and down the space, and theoretically cheaper cost than NASA can do it. So any means that you can lessen the overall cost of the program would be obviously more attractive, particularly to the governments and who, for the bigger ventures outward, are going to have to sponsor, would be happy to take advantage of those.
Now we have a question, a special question from a 10-year-old boy, Daniel Nakar.
Basically, through Apollo 11, through Apollo 7, Apollo 8, 9, 10, and leading to 11, we launched every 2 months. And we normally were assigned a mission with the thought of it being a 3-mission cycle. So in other words, I started on Apollo 8 and possibly would have flown Apollo 11. And conversely, I flew 13, which put me back in the lineup to fly 16 and then 19. So basically you had 6 months. So you had, through 3 missions, you had 6 months to train and get ready. Through Apollo 11, at least my Apollo 8 and 11 assignments were very difficult, lots of hours. In fact, Apollo 8 was the toughest because we changed the mission. We trained for almost 2 months for an Earth orbital mission with the lunar module, and that did not happen. We ended up, the lunar module could not be ready. So it changed to the first lunar mission with just the mothership of the command module. So we really only had like 4 months to train for that mission. And part of the initial part was not training, it was figuring out how we're going to do it and developing the flight plan, developing the training. So we had even a much shorter time. So the last 2 months of that training cycle, we were at it like 7 days a week. And it was like 8 in the morning till about 10 at night. And so that was the ritual. Feel we figured out everything and we're going to be prepared to go.
Oh, so interesting. This is the next question.
I guess you're thinking of looking back. Looking back, I frankly feel very privileged and fortunate to have had the chance. I told you I was very disappointed at the time of Apollo 13. And again, on 16, when about 4 months into training, I realized 19 was canceled. So it was kind of a second point of disappointment that I wasn't going to get to go back and try it again. But, you know, a lot of years passed. In fact, we're in the midst of celebrating 50th anniversaries. In fact, next Saturday, this coming Saturday, in fact, I'll be at the Apollo 10's 50th anniversary in Weatherford, Oklahoma, at a museum there. And of course, there's a lot of celebration in July for Apollo 11, 50th year ago on their first landing on the moon. But those years, I just look back and say I was very lucky to have been literally born at the right time, to end up accidentally as a pilot and have the right credentials to qualify and be a part of the program and at least be one of 24 people who got the chance to go to the moon, even though I didn't get to land. So I feel lucky because there's not been another Apollo program. No program has been like Apollo since.
Okay. I will read the next question. What do you think about NASA and Jeff Bezos' announcement that humans will return to the moon in the next 5 years and the building of the lunar orbital platform?
Well, I think it's great. It's unfortunately a lot of years late. We really felt closing at near the end of Apollo, that we would just continue and keep moving outward. Had a lot of momentum, and of course we saw that didn't happen, and many years have gone by. So I'll just say it's about time. Of course, the key question is, to really make that happen, you need to keep looking at the NASA budget. And I just noticed in today's news, in fact, that the president has asked for, I think it was 1.9 billion to be added to the NASA budget, to get a quicker start. Because, for instance, the lunar lander is mostly a paper for a crewed vehicle. So it's a long ways from cutting metal to building. And so it really needs a quick start to get that down the road. The lunar platform is not new, incidentally. Dr. Mueller, who was head of the Apollo program, had a study done, and part of that study, way back, I'm talking in the 1960s, late 60s, involved a space station both at Earth and one at the Moon, to have a, if you want to call it, a logistic train to support a colony, for instance, on the Moon. You want to call it much like the Transcontinental Railroad in the United States. You have to have a pathway somehow, if people do land and intend to stay, to at least in the early part, to keep supplies going. And so it's not new in that sense, but it would, I think, would be essential if you're going to stay on the Moon.
Okay. The next question is, who do you think is right? Elon Musk, who wants to go to Mars first, or Jeff Bezos, who wants to go back to the Moon first?
I have no idea how to answer that question. It's always going to involve money, no matter who does it and which direction. Hopefully, you end up doing both in some time frame. I think the Moon would be easier to do. It's a much easier mission than going to Mars. Mars is much more difficult in many regards. Obviously, the long term to get there and back, radiation that you have to deal with. So it's a much more difficult mission than going to the Moon. So if you're interested in a quick program, I think going to the Moon is the one that's been set in place, and obviously it's possible to be accomplished maybe in the time frame proposed.
Hi, do you hear me? Good.
Yes, sir.
My name is Nir. First of all, it's an honor to speak with you. I want to ask you some question regarding Apollo 13.
Okay.
Very often, mostly in Hollywood films, there is the tendency of exaggerate and a little bit manipulate the reality events for the sake of the movie. As someone who can tell us firsthand, of course, how strong is the correlation between the events in reality and those who appears at the movie Apollo 13? And also, I like to ask, do you acknowledge when it's happened, when the problem has happened, the immediate danger that you are getting into? And do you have been able to make assessment of the probability of your survivor, or the situation and the high adrenaline didn't give you the time to do this or to be in fear, but you immediately act and start to fix the situation?
All right. I'll tackle the last part of your question first. When this explosion, and actually it was not an explosion that we would normally think of down here, where you set off a bomb and it has the initial flash, pressure waves, and shrapnel that would go out in different directions. We fortunately didn't suffer an explosion that way. Basically, what happened was the electric short in the tank ignited, and materials that could burn, insulation on wiring and things like that, overpressurized the tank, and somehow it failed. It split open, or some of the connections let loose. We did not get back. We don't know how exactly that happened. But it overpressurized in that compartment, and 1/4 of the spacecraft blew off. And fortunately, we did not have that shrapnel effect, because through a very thin aluminum wall behind those tanks was the main propulsion tanks, which had hypergolic fuel. In other words, if you'd have damaged those tanks, the fuel would have mixed, and instantly would have had a much, much larger explosion. And I wouldn't be here talking to you today. But at any rate, what was visible to me, at least, when I returned from the lunar module, that's where I was when this happened, and looked at the instrument panel, it was instantly then a confusion, a lot of confusion, because on the panel is a large array of lights called caution and warning lights. And it's a panel probably about that big, and it has red lights, about half of it. The red lights mean this is something pretty bad. And then you have some yellow-orange lights that are called caution lights, which again means something's not quite right, but it's not as bad. It's not as bad as the red ones. We had 7 of those lights on. We also had a blue computer restart light and the big master alarm light. And if I'd have had a headset on, I'd heard the buzzing or noise of the master alarm sounding. Now, the reason it was confusing was these were across many different systems: the fuel cells, the O2, the main buses, AC buses, reaction control system. Because the spacecraft we flew then were very simple vehicles. Each of these systems were all standalone systems that we operated manually. There was no connection. There was nothing like today in most vehicles. Everything's integrated, including aircraft, through a central computer. Our little computer, incidentally, we hand-wired a big computer on board, was about 1/10 of a megabyte. That's what I said, 1/10 of a megabyte, not a gigabyte. So the computer didn't do much. It did guidance, nav, and control. Everything else in the spacecraft we operated manually. So the reason was, what single failure could have caused those problems across all those systems, different systems that had no relation to each other? So that was the confusion factor. As it turned out, with the help of Mission Control, we found out what had happened was some of the valves, the gaseous and liquid valves and systems, which were open, the G-force of the explosion had rocked them, overcoming spring tension that held them open, and they had closed inadvertently. Not inadvertently, but from the explosion. And we on our panels, the little symbology for open and close told us they were still open. We did not have what Mission Control had through telemetry, the actual state of the valve. So there was some of those valves that were now closed were still open. But anyway, Mission Control psyched that out after a while and had us reopen the switches with a toggle switch, and many of those lights went away. They were kind of what you want to call false lights. So there was a confusion factor for a bit there. The troubleshooting then went on for 50 minutes. So this was not like running off the cliff kind of thing. This was a slow, ascending set of circumstances before it really got life-threatening. We didn't think it was life-threatening. We knew we had lost one oxygen tank, but we had a second one. But then slowly it became apparent it was leaking. So that's when all this troubleshooting went on for 50 minutes to try to isolate that leak. And that's about the time Jim Lovell and I left. and went to the lunar module to start powering it up, because we knew eventually, with the loss of that second oxygen tank, mothership would have to be shut down, which is what eventually happened. Now, as far as knowing our circumstances, chances, it really wasn't until after we then moved into the lunar module, got it powered up, and we did the first use of the lunar module descent engine to get us back on a right path. Because at the time this happened, we were also not on what was called a free return. We were not on a path that would have brought us back home. So the first initial critical thing to do, and Mission Control figured out what the burn should be using the descent engine, was to put us back on a path that would swing us around the moon and get us roughly in a direction to get back for an entry back at Earth. As soon as that burn got over, Jim Lovell asked me to compute consumables. And I assumed, just looking through my checklist, that I could go down to about 18 amps on a 30-volt DC system. My basic system was 30-volt system. And at 18 amps from where we were, and that was a longer return than we ended up with. It was 150-something hours total mission time. I made it on electric power, barely. I ran out of water about 5 hours before entry interface at that time. And I'm not talking about drinking water. I was worried about water for the what electronics we had left on, cooling water. And I did not even compute oxygen. We had lots and lots of oxygen. We had 2 full backpacks. You know, the ones we're going to use when we landed on the moon. They were full up of oxygen, and they had emergency bottles on those to take care of a hole in the suit. Those emergency bottles alone were about 1 day oxygen supply for the 3 of us, if we decided to use that. So I didn't compute oxygen. The one consumable I did not even think of, which was the most critical, was the lithium cartridges that were used to scrub the CO2, the building carbon dioxide. Because as you're in that room right now, if you seal that room completely and y'all kept breathing, eventually y'all would all be in trouble. Because every time you breathe in, you're breathing oxygen, and every time you breathe out, you're putting out carbon dioxide. So in a closed compartment, like a submarine or like a spacecraft, you have to have a way of eventually getting rid of that buildup of the CO2, and we did not have enough cartridges in the LEM to do that. So that's kind of how that story went. So by the time they really shut down the spacecraft, I think it was almost 2 hours. And Jack Swigert did that. We left him alone to go power up the LEM, and he ended up powering down the mothership, which was never planned to ever be shut down in flight. As far as the movie, it was interesting. Ron Howard, I complained to Ron after a special showing about several things. One, I said, you didn't show enough people, because there were a lot more people in what he showed in the movie that had helped get us back. And he just said, you know, in the movie you got a couple of hours, you can only develop so many characters. So, you know, that was his reasoning, and he's right. For instance, there were four flight directors involved in getting us back. He happened to pick Gene Kranz and the white team as the one to portray in the movie. But for every mission, there were 4 active flight control teams that ran the mission. The other thing I complained, I said, you didn't use many of our lines. In fact, the only line in the movie that was our line was, Houston, we've had a problem here. That was it. All the rest of it was Hollywood scriptwriter. And he said, NASA gave me all the air to ground and for the whole mission. And I listened to it, and I realized that no one would understand much of what you were talking about. General public would not. And he said, secondly, I listened to all of that, and it was never apparent to me you had a problem. He said, y'all just talking back and forth about system stuff, and he said, never never came to me that you had a problem. So he said, I had to put some drama in the movie, as he explained it, to make you seem more human. So that was his rationale for some of the. He did some exaggeration where we did the mid-courses, 2 of them manually on the way back without a computer. We did not deviate even 1 degree in attitude in roll, pitch, or yaw, because they were very short. They were very short burns. One was, I think, 21 seconds, and one was like 17, I think, or 18. So the vehicle couldn't have moved very far in that time. And he had, of course, the earth going up and down in the window, like we're about to lose control. So that was, you know, obviously one exaggeration. He had well, greatly exaggerated my throw up. I did get a little space sickness. I spit up, but did not throw up. And space sickness is nice. If you sit still for a little while, it goes away. It's not like being seasick. And that's what I did. I strapped back down for a few minutes, and then I followed the guidance I had been given after that and moved very, very slowly for a while when I moved around. But that's what said it, that's what caused it. I was turning, twisting, and turning, going underneath the couches to get equipment out. That set it off. He had Jim Lovell hugging me. Jim Lovell did not hug me, but the one thing he did not exaggerate, though, was the conditions. It got very cold, and it got very damp. The water tanks on the mothership were found frozen when it was recovered and inspected on the aircraft carrier deck, the hangar deck, after entry. The water tanks were still frozen in that ship. So I assume in the limb where we had our 3 bodies generating warmth and some electronics on, we probably were in mid-30s Fahrenheit. I don't know what that is, 2, 3, 4 degrees Celsius for most of that 4 days. And we had on 3 sets of underwear. I got all spare underwear out. We had 3 sets of underwear on, and of course our 2-piece outer garments. So that was those conditions. Water, the limb has an inner walls that are netting material. You couldn't afford an inner wall for weight control. And you could look through that netting material and we could see water on every wiring bundle and every connector where there was a turn. It'd be a glob of water that had formed there and was sort of shimmering with a little bit of vibration from the pumps running. So water was collected everywhere because the water separator, which these spacecraft had, it was being asked to operate much below its normal specification temperature, and it was inadequate. So same way when Jack Swigert and I went to power up the command module, we had to get towels out to wipe off the instrument panel so we could see the instrument panel. It was covered with water in the command ship as we got ready to power it up. So those environmental conditions were representative. I think I was told they took the movie set down to those relative temperatures when they were filming that part of the movie.
Fred, we have one more question for you. Yuval will ask the question. Okay, we have time for 2 more questions. Okay, Yuval, please.
Good morning.
Good morning.
I wanted to ask, you were part of the project that developed the space shuttle. In retrospect, would you say the space shuttle was a success as a reusable vehicle?
The space shuttle would have been better a reusable vehicle. 2 aspects. One, in Phase A, in the development program, we went through Phase A, which is kind of a concept development, and then you went to a Phase B, which got much more detailed, defined, even some up to drawings. and really getting ready then for what was phase C, where you commit with a contract to go build it. It was a total reusable vehicle. We had a reusable booster. It was going to be manned. Again, all of that would have been different today in several respects. One is we would probably not been unmanned. It would have been unmanned rather, and because again, I told you about the computing assets available. We did not have big computers, a lot of memory in those days, and so I think it would have been more totally automated. And the same way for the ground processing. Everything on the ground we did in turning the vehicle around, including Space Shuttle, was with lots and lots of people manually. Many more things would have been automated and again, a big expense. And the recurring cost of a launch system is payroll. How many people you have working on the program? So the extent you can use automation to reduce the number of people in the reprocessing, the turnaround, the cheaper the vehicle will be to operate. So in that sense, I think we could have done better if we would have been allowed, like aircraft, to build, quote, the next improved generation. I mean, an example would be one of my favorite fighters I flew was an F-86 Saberjet, built by North American Aviation. It was the one used in the Korean War that did a lot of air-to-air combat with the MiG-15 the Russians had. And that was the 86A model that flew in Korea. The best 86, the best Saberjet, was the F-86H model. So it had taken that many evolutions to, what do we call it, get to the best vehicle. And that's the way things evolved. Same way with airliners, as they've gone through the years to improve from the 707 or the Comet or whatever the first vehicles were. And so the shuttle was not allowed to do that. So it was constrained with high cost. There's no question the turnaround cost per the number of flights a year was very high. And so that was, if you want to call it, that was the downside of the space shuttle.
Okay, thank you, Fred. One last question, please.
Okay. I have my question is, how does it feel for the first moment that you exited the atmosphere and you get into space? How does it feel?
Our flight had compared to most, had a little damper on it. I actually, on Apollo 8 and 11, was part of the closeout crew. So I had gone out to the capsule many, many hours before the crew had gotten there and going through setting up all the switches with the launch director, with his wrote commands back and to set everything up for the crew to get there. And I was the last one to leave the capsule on Apollo 8 and 11. I actually had to crawl underneath the couches and come out the other side and crawl out the hatch before they closed it to seal the crew in. I could tell the crews were very, very excited and ready to go. This was they trained and worked toward. They were ready to go. Our spirits were dampened a little bit because on Apollo 13, we went through sort of a medical ritual the week before flight, where every morning, pretty much, they were drawing blood from us to be sent to some expert. I think it was in Cincinnati, Ohio. That was the world's expert on measles, because we had all been exposed and there was a threat of getting measles. So every day we're going through this kind of testing. And 2.5 days before launch, they decided we'd change out a crewman. So Jack Schweigert replaced Ken Mattingly 2.5 days before launch. You have to realize the way we trained as prime and backup, you literally could change out a whole crew. week of launch, and it wouldn't have mattered. The flight would have gone on because we were trained equally, both ready to go fly. So it wasn't that aspect, but it was kind of an emotional down because Ken obviously, Mattingly was very excited. He was finally getting close to the day he was going to get to fly. And of course, Jack had kind of mentally, I'm sure like I had as backup, backed away from the thought of the mission to not be disappointed because you had done all this work as a backup and you weren't going to get to fly. You're going to have to go watch somebody else fly. So it was kind of an emotional flip-flop at that point, changing out a crew. So it's kind of like I was still excited. I was excited to get to fly the mission, but just wishing it would have been more with the crew we'd worked with and planned to go with through two training cycles. So that was a situation that made ours not quite as exciting as I think I saw on the crews that got ready to go on Apollo 8 and Apollo 11.
Okay, Fred, thank you very much. I wish to thank you on behalf of all the audience here and on behalf of Asteroid Day Israel. We enjoyed very, very much to hear from you, your story and your insights. And we wish you well. And as we say, space unite us all.
All right, and here's my buddy again. He's laying here sleeping, but he's woken up to say goodbye.
Okay. Okay. So thank you very much.
All right. Have a good day. Bye bye. Bye bye.